Hello, my name's David, and I'm going to be talking on behalf of Team Juliet. For those of you who don't know, this is Candy Crush, a very popular and addictive game in which players have to swap candies on the board, like so that they form a match. Once a match is made, those candies are cleared from the board and new ones fall down. You have to keep doing this until you achieve some objective, such as reaching a target score. Now it turns out, designing levels for such a game so that they're not too frustrating or too boring is actually a very difficult task. Our job as Team Juliet is to make this task as easy as possible. So what did we do? The first thing we made was a simple interface in which you can manually create and edit levels. But once you've got a level, you need some way of evaluating it. In our software, you can play the level once you've created it. Now, in industry, they typically evaluate levels by running them on large groups of human users. This makes the process very slow and iterative. So what we did was create a range of simulated players. In our software, not only can you play the level you've created, you can watch simulated players play it too. And if you're too impatient to watch it, you can run a whole batch of them in the background and have them return results back to you in a matter of seconds. This makes the process of evaluating your level very quick and easy. Not only that, we took this a step further and allowed the designer to loosely specify what they want out of the level. For example, they could specify what type of level they want, how difficult they want it to be, the range of moves the user should have, and so on. Once they do this, they can hit go, and we'll make the levels for them. Now, of course, these won't always be perfect, so we still allow you to edit them even after they've been generated. And we believe this provides level designers with a very strong starting point for making very good levels in a matter of seconds. So how do we do it? The first thing we needed was a working implementation of Candy Crush. And since there were no open source solutions to this, we built it ourselves. The features that we included were these. I'm not going to explain all of them, but basically they have different effects on the board, and when you combine them, they have further different effects on the board. We added support for high score levels in which you have to reach a target score, jelly levels where you have to clear all of the jellies on the board, and ingredient levels where you have to sink the ingredients down to the bottom. We made a range of simulated players, starting off with the dumbest player, which would pick the first move it finds. A slightly smarter player would find the longest match, so prefer a match of 5 over a match of 4. We made some rule-based players which were slightly smarter, and then the smartest were based on the A-star search algorithm, with increasing look-ahead and pool size for better play. This worked by defining 2 functions, a metric function which kind of gave us an idea of how far away a board state is from the target, and a potential function which gives us an idea of how likely that board state is to reach the target. Using these, we then sift through the game tree and pick out the most promising board states to explore. And for those of you wondering, humans, luckily, they fall about in the middle, some a bit lower, but this was quite good for us. In terms of matching up simulated players with human play, it was quite useful. Finally, for generating level designs, we used a genetic algorithm, which starts by generating an arbitrary population of designs, so they're all randomly initialized. We then calculate the fitness of each design in terms of how aesthetic it is and how playable the game is. We then combine the fittest, like reproduction in evolution, and then mutate them, again like in evolution, and repeat this many times. We did this in several threads, and once each thread is finished, we'd pick the best design from each population. We'd then run the simulation players on these, and they would assign objectives to the game, such as the score you have to reach, the number of moves you have, the number of ingredients you have to drop down, and so on. Now, hopefully you all saw this earlier, but I'll show you some examples of levels that have been generated. It's quite hard to tell how difficult or how fun a game is without playing it. So again, I hope you all had a chance to do that in the demonstrations. Here's some more. And thank you very much for listening.